These are the most missed test questions from last week. If you want to retake the test, then copy down these questions and answers. Okay, it helps to have a hexagon. I had to get my hexagon. Here we go. Looking at sine times cosine, remember if you multiply, they equal the one in the middle, and these don't equal. There's nothing in the middle. So let's go to the next part. Let's look for this. 1 minus cosine squared. That looks a lot like a Pythagorean, and it is. Remember this shaded triangle? And this triangle, remember, this is your Pythagorean theorem. A squared plus b squared equals c squared. So if we're doing 1 minus cosine squared, 1, which is like your c, your hypotenuse, minus a cosine, which is your b. A hypotenuse minus a leg is a positive number. And remember, this is Pythagorean, so it's not just sine, it's sine squared. So the bottom is actually sine squared x. Okay, also remember that when you have sine squared, there's actually 2 of those. And these are singles up here. So you got to be careful about canceling. Better way to write it would be like this. There we go. Sine squared x is sine x times sine x. And I just copied the top, keeping it the same as the original problem. Now you can easily see what cancels out. You have a sine x that cancels out. And then you're left with cosine divided by sine. Cosine divided by sine. Remember that rule? Kind of cut off the answer there. But when you divide, the answer actually comes before the problem. Cosine divided by sine. The answer is like, you know, the 1 step forward. The answer is 2 steps back. The answer is over here at cotangent. So this should have been B. Okay. This is a reciprocal rule, 1 divided by sine. Remember, 1 divided by sine is actually cosecant on the diagonal. And if this is squared, then that will be cosecant squared. So let's write cosecant squared A. And I'm just going to keep that minus sign in between and do the reciprocal rule for the second fraction. 1 divided by tangent over here is cotangent. But if this is squared, your answer is going to be squared. And then I think we can take that further because that looks like a squared plus b squared equals c squared, or subtracting version of it. So let's see. Cosecant squared minus cotangent squared. Okay, so using your Pythagorean rule, a squared plus b squared equals c squared. If I had cosecant squared at the bottom, that would be like a hypotenuse, c, minus a b. Hypotenuse minus a leg would be a positive a, because hypotenuse is bigger than the leg. So this would be a positive 1. So that would be A. Okay, my first rule of thumb is to look for the hexagon identities. Looking at the first, secant squared minus 1, secant squared minus 1, and that's looking like Pythagorean. Okay, so this is your Pythagorean triangle, a squared plus b squared equals secant squared, c squared. So if I'm going backwards, secant squared minus 1, that would be like a c, hypotenuse, minus a leg. Big number minus a little number is a positive number. And remember, this will be squared, so that's not just tangent, it's tangent squared. So the top just turns into tangent squared. And remember, if there's 2 on top and only 1 on bottom, I'll use x instead of theta. Then when you cancel, there's still 1 left. take a minute to write it down. Tangent squared, you have two of them on top, so when you cancel, you still have a tangent left on top. If it were on bottom, 1 over tangent, and you'd have to do the diagonal rule. But in this case, it's just tangent. So there we go. Okay, in the proof, you can see from this step to the missing step that you have to fill in, the cosine squared stayed the same. What changed was that 1 minus cosine squared has changed to sine squared. See that? 1 minus cosine squared changed to sine squared. Remember what rule that is? That shaded triangle is the what? Pythagorean identity. Okay, so in this slide you're figuring out what replaces the crossed out portion, and it tells you right there you're going to use the cofunction identity. So look at your green sheet, look at the rules bottom corner where it says cofunction, and there's similar, only thing's different is x and theta. It's just a different variable. So that it gets replaced with cotangent. Okay, you have a problem here that doesn't match up. Cotangent squared times tangent. So you have two of those and only one of those. What do you need to do? Okay, I hope you said write it out, which I did. Cotangent squared, there's two of them. So if I multiply them together, I'm just back where I started. Don't want to do that. So let's try multiplying these two together instead. What is cotangent and tangent multiply to give you? 1. And then 1 times anything is itself. So that's cotangent. Alright, this one follows the multiplication rule, and we don't have any squares, they're all singles. Let's try, you can multiply them in any order. I'm going to see if the first two multiply to be anything. So cosecant times sine. Let's see. Cosecant is CSC times sine. They do multiply to be the one in the middle, which is 1. So those two multiply to give you 1, and 1 times anything is itself. So that'd be cosine. Okay, if I try the hexagon first on this one, secant minus cosine, secant subtract cosine. The only subtraction rules we have are Pythagorean. For one thing, those are not squared, and secant and cosine they multiply to be 1, but they don't subtract to be 1. So we need another strategy on this one. What do you do with a number outside a set of parentheses? You can, well, one thing you can do is distribute it, multiply it by both of those. Let's try that. Okay, so if you multiply secant times secant, that's secant squared, and then we'll bring my minus sign over. Secant times cosine. What do secant and cosine multiply to be? The one in the middle. So that would be 1. I'll bet you that's something else. Let's look. Looks kind of Pythagorean to me. Secant squared minus 1. Secant, there's secant. There's a 1. Is that a shaded triangle, or is that a shaded triangle? This one over here. And the one at the bottom is your hypotenuse. That's your c squared, and your a squared, and your b squared. So c squared minus b squared would be a squared. So not just tan, but tangent squared. Okay, first glance at this one, 1 plus sine, if I try to do the parentheses first. The only way I can add them is if they're Pythagorean, and we do not have a squared on that term. Or that one. So right now, you can't really do anything to the parentheses, 1 plus sine. So what's another thing we could do with 1 plus sine? What if it were just, not trig? What if it were just 1 plus x and 1 minus x? What would you do with that? It's one of those difference of squares. So if you fold it out, multiply all the terms, it looks like this. And in those difference of squares problems, the terms in the middle, -1 plus 1 is 0, so those are going to cancel out. And we're just left with 1 minus x squared. Now, instead of x, this problem had, what, sine? So putting the trig back in it, what's 1 minus sine squared? Well, 1 minus sine squared, that's like your Pythagorean problem. 1 is your hypotenuse, your c. So the hypotenuse minus that leg would equal the other leg squared. So cosine squared. Okay, this is one of those you just kind of have to remember seeing it, because it is different. To me, this is the hardest problem on the whole test, because it's not something you think of. Sometimes you got to make it bigger before you can make it smaller. This is one of those. And it follows with the last question too. 1 plus sine is not Pythagorean because one thing is not squared. That's a big giveaway. So we got to do something with the top, because you can't add the bottom unless there's Pythagorean. So what can we do with the top to make it sort of look like the bottom? Cosine squared. We could... Okay, so cosine is like your b squared term there. So to get this term, we could do c squared minus a squared to get the b squared. So I'm going to do 1 squared, which is 1, minus sine squared, and replace that. Okay, so see what I did? I just left the bottom the same and replaced the top. 1 minus sine squared to get cosine squared. Now, that we just did on the reverse of it on the last problem. We're going to factor it. How does it factor? Okay, so there it is. It's a difference of squares. So 1 comes first. 1 times 1 is 1. And sine squared, sine times sine. Now we can cancel 1 plus sine x out, and there's the answer. 1 minus sine x. Okay, I rewrote this so it looks more textbook pattern. So it's 1 minus sine squared divided by 1 minus cosine squared. This on top, direct Pythagorean. 1 minus sine squared is like c squared minus a squared, which would be b squared, or cosine squared in this case. Okay, bottom. 1 minus cosine squared is like saying c squared minus b squared, which would equal a squared, or sine squared. Okay, now you have the divide rule. You have cosine divided by sine. That's your consecutive outside edges. So cosine divided by sine, remember it goes like this. Cosine divided by sine, 1 step forward, 2 steps back, so the answer is cotangent. But if these are both squared, it means you got a pair of them, so this would be cotangent squared x. Now this one just looks scary. It wasn't at all. It was quite easy, as a matter of fact. So if I'm looking at the parts of it, the top, this cosine squared plus sine squared, you should have that one memorized by now. Isn't that your Pythagorean? Yes, that's your Pythagorean. So even though it's a little b, it's like saying cosine squared over here, b squared, plus a squared. Does it matter what order you add a and b? No, it doesn't. Either way, they both equal c squared, and 1 squared is 1. Okay, so now we have 1 over cosine. That's your reciprocal, your diagonal rule. 1 over cosine. 1 over cosine is secant. Okay, so 1 over cosine is secant. 1 over cosine is secant. Diagonal rule. So all this now is just secant. So now let's look at this part. What's 1 over secant? 1 over secant is another diagonal. It's cosine. So we'll change that to cosine. And if we multiply them together, cosine and secant multiply to be 1. Okay, this one is 1 minus secant squared. Of course, that's Pythagorean. Here's your 1, there's your secant. But we need to think about this for a minute. If this is b squared minus c squared, then you have a leg minus a hypotenuse, which is a little number take away a big number. So that's not just tangent. And it's not just tangent squared. It is negative tangent squared. When you subtract little, take away big, you get a negative. Okay, last one, and this one wasn't missed as much as some of the others, but this is your dividing rule, sine divided by cosine. So let's find those. There's sine, there's cosine. So if you do 1 step forward, 2 steps back, tangent is your answer. Remember, the answer comes before. Tangent is sine divided by cosine. And since both of these are squared, the answer is tangent squared. Good luck on your retest.